Okay, students, we're going to go over dilation questions. I told you dilation is big on the DCAS, or at least it has been, so I'm assuming it's going to continue that way. So these are, again, prior problems. So work on memorizing these concepts. All right, parallelogram JKLM is drawn on the coordinate plane. Which information must produce a parallelogram that is similar? Remember, similar can be congruent or same shape but different sizes. Remember, similarity, so if it's congruent, it's a rigid motion. So any rigid motion will be similar because that's therefore congruent. Remember, that's the definition of congruent. I can get from the pre-image the image by any combination of rigid motions, also called isometries. Okay. And secondly, similarity comes from dilations. Remember, the dilation rule is xy maps onto ax comma ay. Now I should say absolute value of a almost, because I could have a negative or a positive of the same number. That just refers to a reflection over the x-axis or the y-axis as well. All right, a transformation that doubles the x-coordinate and divides the y-coordinate by 2. That can't be. It has to do the same to both. That's the absolute value of a and a. Okay, so that's out. A dilation with scale factor of 2, followed by dilations with a scale factor of 1/3. So those are dilations. Dilations good. Similarity. A transformation that adds 1 to each x-coordinate and multiplies each y-coordinate by 2. Can't have that. It's got to add or subtract to both the x and the y coordinate. It doesn't have to be the same number. It has to add or subtract, or it has to multiply by the same coordinate. So that does not work. A dilation was centered at the origin, scale factor of 3, followed by a reflection. Yes, a dilation is good and a reflection is good. So yes. Transformation that triples both coordinates of each. Yes, that's a dilation itself. So those 3 would be the answer. All right, quadrilateral is graph and coordinate planar. Which transformation would the image be similar? So now we're going with the rule, similar. Okay. A works because that's the absolute value. And so what that does is doubles each of those and then take the negative x to be reflected over the y-axis. Okay. So that's a reflection over y-axis, which is the x-coordinate, to negative, and a dilation of 2, scale factor of 2. Okay, that's what that is. This cannot happen. Can't have different numbers here, so that can't work. This can't happen because it adds and then multiplies. It has to only add or subtract. So if this is y plus 5, that'd be fine, or y minus 5, or y minus 3, that's fine. But you can't have an addition one and a multiplication one. Make sure you know that. And this one doesn't work. Again, the same idea. Okay. Can't have both an addition or subtraction and a multiplication. Triangle ABC is dilated by a scale factor of 1/2. Okay. And center P to the triangle DEF. So DEF is half of ABC with the center at P. Let's see, apparently, so it's a dilation. So what do dilations preserve is what it's really asking. Dilations preserve what? That's the question. Parallelism, remember parallelism one. So I'm guessing AB corresponds with DE. So AB corresponds with DE, yes. So they're going to remain parallel. Okay, AB, DE. That's true. Angle A and F. So that's the angle measure is preserved. Okay, so we have parallelism is preserved. Angle measure. Now it has to be the corresponding, so we got to check to see if those angles match up. Does A match up with F? If so, that's true. Does A match up with F? A matches up with D. So no, it's not true. A and F do not match up. You got to check that. B and E, do B and E match up? B matches up with E. Yes, it does. So that one is true. The length of segment AC is twice the length of D. No, AC, that was the one that was half. That was the image. Wait a sec, let's make sure. AC, I think it was. Oh, no, yeah. No, that is the pre-image, so it is double. AC is double DF. That's true. Let's see if that's what that said. AC is double the length of DF. Yes, that one is true. The length of segment EF is twice the length. No, that's half. That's the one that's half. The distance from P to D is equal to the distance from P to A. No, that should not be true. P to D is not the same distance as P. P to D is 1/2. This is 1/2. If that's a half, that's a full. That's VA is double. Remember, that's the other way we can check. We can check the corresponding lengths, or we can check from the center of dilation to corresponding points. Remember, don't forget, it's image over pre-image. If you're checking those lengths, image over pre-image. This happens just to be checking what it preserves. You gotta know it. The distance from P to D is equal to distance. No, so that the distance from P to B is twice the distance from P to E. That would be true of B and E match up. Do B and E match up? B and E match up, yes. PB is double the distance as it is from P to E. So that one's true as well. All right, segment AB has endpoints there. The segment is dilated about the origin by a scale factor of 0.5 to create this. So when it's about the origin, I can just take half that number, so it's a scale factor of that, and apply it to each of these points. So A prime is now -1, 4, and B prime is now 2, 0. Okay. What are the endpoints to segment A prime, B prime? -1, 4, and 2, 0. And that's because it's centered at the origin. Okay. If it was not centered at the origin, remember, we would have to use the slope and count and do it that way. So those are two right there. Okay, which lines will not be changed by the transformation? Select all that apply. So the ones that won't be changed is if the center of dilation is on the line itself. The image will go into dilation centered at point B. So every line that contains point B will not change. Remember, if the point is on the line, it does not change. So the line AC, yes, that is on it. AE is not on it. BE, yes, that's on it. Okay, CD, nope, that's not on it. And DE, nope, that's not on it. So just those two. Okay. Graph the line of the equation right there. Remember, that's a standard form. The two easiest points to plot in the standard form are the X and Y intercepts. So that's 3 times 4. So when you make that 0, so that's 4, 0, which they have plotted there. And make that 0, and this becomes 6, 0, 6 is plotted there. So they've graphed it for you. Line M is the image of line P after dilation centered at the origin. That's nice and easy now. Is at the origin a scale factor of 2. So remember, the slope stays the same because parallelism is true. It says graph line M by selecting 2 points on the coordinate plane. That will be drawn through that. Okay, so we want to go ahead and solve that for y. So you got 2y equals -3x plus 12. And divide each term by 2. So you have y equals -3/2 x plus 6. Scale factor of 2. Remember, the slope does not change. And all we do is double the y-intercept because it's a scale factor of 2. The y-intercept is the one that changes. So I have -3/2 plus 12. So it says pick 2 points. So we're going to pick 0, 12, and then we're going to go down 3, right 2. 1, 2, 3, right 2. There's my second point. Okay, pick those 2 points, and then I'll draw the line for you. Okay, got to solve for y first. Okay, 3 pairs of figures are shown here. Select from the drop-down menu to correctly complete each sentence. The figures in pair 1, that's these 2 triangles right here, are similar or are not similar. Okay, so do they look to be, so if I look here, notice I see it's up to right 2, and this is up to left 2. Some of these are the same distance, so that's an isosceles triangle there. And here, this also is an isosceles triangle here. Okay. Are or are not similar because and then you pick which one. So can I get that over? Well, I could reflect this over this here. And you put it right there. That would put that there if I reflect over line BD. And then the question is, if I dilate that, it's not going to be, because yes, I can dilate that to make it go out to here, but then don't forget that's going to extend these out further this way. So they're not similar. There's no combination that's going to get to this. Okay. You have to be able to imagine that. All right. So next one. Figures in pair 2. Are they similar? So go back. Look at 2. That distance is 2. That distance is 3. Or it's got to be the same ratio. So what is this distance? 1, 2, 3, 4, 5. And this is 1, 2, 3. Okay. So in order to be similar, that is the same ratio. Okay. So 2/3 is not the same as the 3/5. So that is not similar. Okay. And the last one is, so is it pair 3 as well? Going through pair 3. Are or are not similar. I think these ones look similar. See, here we go. 1, 2, 3, and then 1, 2, 3. So that's a 2-to-1 ratio. And that's 1, 2, 3, 1, 2, 3. That's a 2-to-1 ratio. So these are similar. You could have a center at J and a scale factor of 2. Double that scale factor and it puts it there. So 3 is similar. Okay. So this would not, because of this one right here. We can get this from here to here, but the problem is this would not be the same scale factor from the first triangle, the small one, to the big one. That's why that one's not. So similarity, checking the ratio of all sides, not just the ones that looked like it. Okay. Dilated from center D. We can know that because remember, we can go right through corresponding points and where they intersect. That is the center of dilation. That's a quick review of how you find the center of dilation. Okay, select the dart runner complete. In the figure, the length of any line segment in the image. Okay, so they must have, so they don't have the primes. We have to go back up and look which one they said. ABC has been dilated, so ABC is the pre-image, and this is the image. So it's an enlargement because it got bigger. The length of any line segment in the image is longer, okay, than the length of the corresponding line segment in the pre-image. The scale factor of the dilation is what? 1 or 2? Okay, the easiest one to do, remember, is check a vertical or a horizontal, because I can easily count that. 1, 2, 3, and 1, 2, 3, 4, 5, 6. So image over pre-image. Remember, I over P, alphabetical order, easy to remember. So we have the image, 6 over 3, which is 2. So the scale factor is 2. Triangles are shown here. Conditions about the triangles are given. Angle S is congruent to angle U. Angle S is congruent to angle U. SR is the image of UP under dilation. SR is an image of UP under dilation scale factor of 2. So of UP. So we call this X. This is 2X. Okay. ST is the image of UW. ST is the image of UW. So again, that's X. That's 2X under scale factor 2. So that tells you those are similar. How do we know that? We have SAS similarity. SAS similarity right there. Okay. UQ is the image of UP under dilation of 1/2. Well, so these are not going to be similar because their scale factors are different. Okay. So those are not going to be similar there. We only have UPW is similar to SRT, for example. UPW, SRT. Determine whether they're similar. That's true. UPW, this outer one, compared to UQW, no. And UQV to SRT, no. Okay. Because you can see that there are different angles. Okay. Different ratio lengths there. So no, right there. Okay. Which transformation on quadrilateral 1 can be used to verify that it's similar to quadrilateral 2? Okay. So if it's similar, we know it's a dilation. So we see dilations on all these here. We know if we go through it, if we go through the corresponding points, it's going to center at the origin. So it's centered at the origin. Okay. Origin, so that wipes out this one. Okay. Which transformation on quadrilateral 1 can be used to verify that it's similar to 2? So is it a dilation by a scale factor of 1/2? It's got to be done to 1, so it's going to be half. Okay. A dilation of 3/4. It is smaller, so it's got to be less than 1, so that's good. That's good. Dilation of 2. No, that can't be. Okay, that'd be going from 2 to 1. We're starting at 1. Which transformation on quadrilateral 1? So 1 is the pre-image. Okay, pre-image. Number 2 is the image. So the question is a scale factor of 1/2 or 3/4? Okay, so I can take the horizontal. I have horizontal right here, right? If I move this out, oops, get rid of, change it back to there. Move that out so you can see it easier. I have this horizontal or vertical, it doesn't matter which one. If I do the vertical, I have 1, 2 length there as the image, and the pre-image was 1, 2, 3, 4. So that's a scale factor of 1/2. Okay, and it looks half the size. So there's your answer right there to verify it. Dilation centered at C. We can see that because it going through corresponding points intersect at C. Scale factor of K, where K is greater than 0, so that's an enlargement, which you can tell because that's the image here, and that's the pre-image there, and it's image over pre-image. Okay, for any point P on CP, the point P prime is on ray CP, and C P prime equals K times CP. That's what the scale factor, K is scale factor. Use this definition in the diagram shown to prove the following theorem. AB is the image of B after dilation center at C with scale factor K. Then AB restriction on how to use the diagram to prove the theorem, show justifications. Okay. In your proof, I'm just going to verbally talk about it. So this K comes from doing C, you can say CA prime divided by CA. Okay. That is the same as getting the CP prime equaling some number times CP. Okay. So that K is doing the C to A prime divided by C to A. Okay. That's going to give you some value greater than 1, calling it K. Okay. And you can just write that out. All right. Vertices there. DEF has vertices there. Select from the drop down menu to correctly complete the sentence. The triangles are similar because DEF is the image of ABC under dilation with center blank and a scale factor of blank. So this is where you'd plot these points, go through corresponding points, A through D, draw a line through A through D, see where it intersects, and say C and F. Okay. So if I was to quickly do a quick sketch of that, 2, 1, 6, 3, 3, 4, 5, 6, 2, 3, and 1, -2. 1, -2 there. We'll change the color. Red. 1, -2, and 4, -3. 4, -3. So if I go ahead and remember, if I take my corresponding going through this here and going through this here, quick, wherever this point is, maybe it looks like maybe -1, -1, just quick guesstimate. But if I had it in the coordinate plane, I'd be able to do that. That's how you'd find it. Draw it on your own coordinate plane. Use a straight edge, go through that, find the center of that, and then the scale factor. Okay. You can do whatever that is, do the, like we just did before, center dilation. So let's say, center dilation, DEF. Draw that triangle to there and its corresponding point from there to there, for example, whatever the corresponding points are on the two triangles. Pick them or calculate any length of corresponding sides and divide image by pre-image. Okay, so here's one that we had done before. We actually did this problem on one of the other ones. I'll quickly do it again. Okay, this time I'm just going to go faster. Tangents, 90 degrees, tangent, 90 degrees. Okay. PB is 6, BC is 6. So BC, which makes both of these 3s. Okay, that's the diameter, so half of it. Call this X. This is congruent to itself. We have AA similarities, so the two triangles are similar. Okay, so this is 3 and this is 6. Those are radii as well. So we have a full length right here, full side compared to a full side. So the ratio of the two triangles, and we have that triangle there and that triangle there. The ratio, since we have a full side here and a full side here, corresponding side, the ratio is 3 to 6 or 1/2. So now we can find the ratio of these full lengths. Okay, so the small one is this length from here to here. That's X plus 3. And then the full length there is x plus 12. Okay, and now we can cross multiply. You gotta put parentheses around these. So you get 2x plus 6 equals x plus 12. Subtract that across. Subtract that across. X equals 6. Okay, so now we have, and now I'm going to blow up this smaller triangle right here. Right angle there. That's my E, D, and whatever this is right here, M. We know this is 3. We know the hypotenuse now is 9. And so we're looking for DE. So now I have right triangle, so we can do Pythagorean theorem. So I have x squared plus 9 equals 81. Subtract the 9 across. I get 72. Square root both sides. They didn't even simplify it. They left it as square root of 72. That would reduce down to 36 times 2, which is 6 root 2 if they had actually simplified it. Okay. Figure AC and PQ intersecting at B. The lines will be the images of lines A, C, and PQ, respectively, under a dilation centered at P with a scale factor of 2. So since this P is on this line is not going to change, but since the scale factor of 2, this AC will come out here somewhere, being twice as far. If that's X, then this whole length here is 2X, for the whole length, twice as far, okay? So select from the drop-down menu, line A prime, C prime. Here's my A prime, C prime. Will be blank to line AC. It'll be 2 times, well, it's not 2 times long, all lines are the same length. It's 2 times as far away from P. And line P prime, Q prime will be the same. Okay, so this might say we will be dilated, perhaps, by a scale factor of 2, and this will be the same because the point center of dilation is on the line itself. Okay, next one, you have these right here, these 2 triangles. What's the scale factor and the center of dilation? I'll carry it ABC onto DEF. So center of dilation, remember we just connect these. So it's going to be at the origin. Okay, right there, centered at 0, 0, the origin. Scale factor, or we just take 2 corresponding sides. We want to take either horizontal or vertical if we can. 1, 2, 3, and 1, 2, 3, 4, 5, 6. Okay, so now that will carry ABC. So that means this is the pre-image, just the image. And so don't forget it's image over pre-image. So it's 3 over 6, which then is 1/2. You got to reduce it, scale factor of 1/2. In the coordinate plane, P has a slope 8 and a y-intercept of 0. Line R results in dilating by line P by a scale factor of 3, centered at 0, 3. So we know the slope doesn't change. So slope of 8 wipes out those 2. Okay, now it's not going to be at 0, 5 because it's got a scale factor of 3. So that automatically wipes that one out. So you have to figure out that it's at 0, 9. Now here's a quick reminder of how to do that in case you have one where you have to figure out where it is. So 0, 3 is right here. Change that color. 0, 5 is right here. That was this y-intercept. Well, remember, if I go from the center of dilation to a point on the circle on the line itself, okay, that's scale factor of 1. So going up by 2 equals scale factor of 1. We got a scale factor of 3, so we had to go 2 more 2's. There's 2 more. So from 5 plus 2 is 7, and then 2 more. 7 plus 2 is 9. Okay, so that's a scale factor of 3. So now we see why it's 0, 9. Okay. 4. Okay. Determine if these 2 figures are similar. They're similar, they're going to come through the same point. Looks like the origin is center of dilation right there. And you could triangle similar to which we can determine by probably a scale factor of some number centered at the origin is what you're having to figure out. Um, so you could go from here, the origin, figure out the length to two corresponding pairs of points, find there on a couple of them, but you could also say, well, I'd have to see what their combinations are, but we know it's centered at the origin doing that, and it's gonna be greater than 1 because the image is bigger than the pre-image. Okay, so maybe it's like 1.2, 1.3, something like that. All right, so here we have similar triangles. Those are overlapping triangles right there because they're both right angles and they share that in common AA similarity. Okay, so that means the corresponding sides must be proportional. Okay, a post is 5 feet tall is attached to a support. So 5 feet tall is attached to a support that is 4 feet from the base of the support is attached to the ground. A post that is 5 feet tall is attached to the support. Here's the support. And is 4 feet from where the base of the support is attached. Okay, to the ground. I think right there. Okay. It's 4 feet from the base of the support. There's the base of the support. Is attached current. Yes, right there. In the figure shown, the distance in feet from the base of the billboard. So now we want to find this. Well, so notice we don't have the height of that, so we need to find this first with Pythagorean theorem, and then we can compare correspondingly. Okay, so 25 plus 16 is square root of 41. Okay, and so corresponding sides, I'd have 4 compared to x, meaning the whole thing, equals square root of 41 compared to 26 being its entire length. I cross multiply x square root 41 equals 104. And last step, divide by square root of 41 on both sides. Okay, and that's going to be my answer. And create an equation to use to determine x. So you have that right there. Okay, so there we go with that right there. And then that'd be exact answer, and you can say approximately equal to whatever it is. Okay, in the coordinate plane. Oh, we already did this one. Okay, so let's see, same slope. We already did this one. Oh, so dollar apply is similar to KLM. That looks like it is. Okay, looks like it's gonna be similar. Okay. Dilation of scale factor 0.5. It's not 0.5. It's not, obviously it's not half of it. So dilation of scale factor 1. It's not exact 1. It's dilation of 1.5 centered at the origin. That's what it looks like it is. So translation would be the exact same size. It's not. It's bigger. Okay. Remember, translations, pre-image and image are congruent. So we have that right there, A and E. Okay. So here's that one. Plot them. Find where they intersect. That's the center of the, go through it. Find the center of dilation and then the scale factor. Okay, we've done that enough already. Okay. ACP images. lines AC respectively under dilation with center P. So again, this line PQ will not change, but that is, it'll remain parallel to it. Line A prime C will be parallel to AC. That's true because of parallelism. And PQ will be parallel to PQ. That's true because there's the exact same line. Okay. That's parallel and it will be the same line. So that's even more accurate. Okay. So it's the same line. That's the one they want to see right there. Okay. PQ prime is the same. Remember, if the center of dilation is on the line remains the exact same. It does not change. Okay. What's the scale factor center dilation that maps ABC onto DEF? So negative 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 2, 6. 2, 1, 2, 3, 4, 5, 6. And 2, 2. 1, 2, 1, 2. Okay, center dilation, we can see going through those is 0, 0. If we go ahead and take corresponding side, that's 1, 2. Maps, what was it? Maps ABC. So ABC is the pre-image over the image. Remember, scale factor is image over pre-image. So the image 2 over the pre-image 1, 2, 3, 4. So scale factor is 1/2. Center at 0, 0. Scale factor is 1/2. Center of dilation is the origin. Okay, here we have one centered at the point 0, 6 now. Well, notice 0, 6, first thing I'm checking is 0, 6 on that line. Yes, it is. I plug in 0 there, I get 6, so that gives me Y is 6. So 0, 6 is on the line. So remember, anytime center of dilation is on the line, the equation of the line is the exact same. So Y equals negative 3x plus 6 is my answer. Okay, ABC there. D is 1, 2, graph there. After dilation, scale factor 2 centered at the point D. So here's my center of dilation now. So I'm going to go out, remember, to get to that point, that's a scale factor of 1. I go down 1, 2, 3, right 1, 2, 3. So down 1, 2, 3, right 1, 2, 3. So there's C prime. How do I get to change the color to A? Down 1, right 1, left 1, 2, 3. Down 1, 1, 2, 3. So there's A prime. How do I get to B? Change that color green. Left 1 and up 3. Left 1 and up 3. There's B prime. Okay, so there's my new triangle, scale factor of 2. Okay, use a slope. Okay, scale factor is a segment is a line segment is dilated by a scale factor of 2, centered at a point not on the line segment. Which statement regarding the relationship between the given line segment and its image is true? It's going to be parallel and same slope. Line segments are perpendicular. No, they're parallel. Line segments are parallel, and the image is twice the length. Yes, it is. Since it's not on the line segment, boom, it's going to be twice. Even if it was, it's going to be twice. Okay, so 3 is my answer. Boy, we must be getting close. Oh yeah, last one. In the diagram below, AC is 7.2, CE is 2.4. We have vertical angle theorem right there. Should know that. Which statement is not sufficient to prove triangle ABC is similar? So 2.4 to 7.2 is 3 times. So scale factor would be, a ratio would be 3. Scale factor or ratio is 3 to 1. Okay, 7.2 is 3 times 2.4. Which statement is not sufficient to prove? Okay, if I know AB is parallel to ED, well then I have parallel lines cut by transversal, alternate interior angles are congruent, so therefore I have AA similarity, so that works. Okay, if they tell me DE is 2.7 and AB is 8.1. Well, is that 3 times? Okay. It is, but notice that's not one of our, that's not an SAS or SSS similarity. So that one would not be sufficient. Let's check it. CD is 3.6 and that's 10.8. Yes, that's 3 times. And that would give me a SAS similarity. So that will work. Okay, and if they told me DE is 3.0, AB is 9.0, CD is 2.9, and CD is 2.9, and BC is 8.7. That's 3 times as well. Both of those are 3 times. Okay, so now I'd have SSS similarity. So that also proves it. So 2 is the one, because remember there are 3 ways of proving triangles congruent. AA similarity, also called AAA, because if I have 2 the same, the third has to be SAS similarity or SSS similarity. And remember, the S's have to have the same ratio, which they all were, 3 to 1. The angle measure has to be exactly the same. Well, we have our vertical angle here, so that is the same. So this one did not give us the SAS or SSS, so it's number 2 that was not sufficient. That's why you have to know your ways of proving triangles similar. Okay, here we have another line. Determine the state and state the equation of line P after a dilation of a scale factor 1/3 centered at the point 4,2. So this is the most difficult one. Oh no, it is not whatever it's centered at. The first thing I want to check is that point on the line? If it is, then it's the exact same equation. So what is 3 times 4? 12. What's 4 times 2? 8. What's 12 plus 8? 20. Yes, so that point is on the line. So it's the exact same equation. Okay, so I could write 3x plus 4y equals 20, but if they want it in slope-intercept form, I need to solve for y. Okay. Divided by 4, that's just all pre-algebra. Okay, so if they wanted the equation in slope-intercept form as that, if they didn't carry, I could have this. The question must have been, okay, determine and state the line of P, the image after. Yeah, so since this point is on the line, it's the exact same equation. So you could just write that back, or if they had y equals, and you fill in the right side, that means they wanted to solve for slope-intercept form, and you put that one in. Okay, that does it. We got through all the dilation ones in 43 minutes.